So we are going to talk about the first concept of differential equation, first order differential equation. This type is the differential equation with separable variables. Alright, so let's look at the examples. Let's say if I have 2 dy dx, okay, the first example, 2 dy dx equals to y x plus 1 over x, right? As you know that this is a first order differential equation, as the dy dx is first order and the degree of the dy dx is 1, right? So for these cases here, this is a differential equation, means that it's a differential form, right? So we have to find the equation, right? The general solution of this equation. So how? So as you see that we talk about separable variables. So you look at this equation, a differential equation here. So you can see that we actually can separate the y into one side and the x into one side. So let's see what I mean here. So it means that if I can separate the 2 dy, as this is I can divide both sides by y, right? As this represent multiply. I can divide both sides by y, so I will have 2 over y is at this side, and y have already removed to the left hand side. So now we have x plus 1 over x on the right hand side, right? And dx supposed to be multiplied by dx both sides, right? So we have separate the variable. Separable variable, we have separate the variable where x plus 1 x dx and dy 2 dy with the over y here. So after we have separate the variable, so we have to integrate both sides, right? As you have a knowledge of integration, so integration 2 over y, you are getting 2 ln modulus y, right? And for this case here, I can simplify first before I integrate, as x over x is 1 plus with 1 over x dx, right? So integrating 1, you are getting x, right? Integrating 1 over x, you are getting ln modulus x. So as this is a general solution, there are no limits. So we just put a plus c here, and this is a solution for this differential equation. As if you differentiate this, you are getting back this differential equation, right? So this is an equation. This is an implicit equation before we differentiate to become a differential equation, right? So we integrate and get back the, but this is a general solution because we know what is the constant for this function here. So as this is my solution, right? This is my solution for this general solution for this case. So let's go for more examples. All right, let's look at these examples. Okay, so as this is a first order differential equation. So as we see that we try to solve this equation, but I tell you that this is a differential equation which can be separate into separate the variable. We can use the technique of separable variable where I can rewrite x y plus 1 dy dx. As I move this goal to the other side, so it will become negative y x minus 1. So now can you see that we actually can group the y together and x together one side, right? So as you see, there is a y here, right? Y. So we divide both sides by y, so means that y plus 1 dy, y plus 1 dy have to stay here, right? And this y have to move to here. As I multiply, as you divide, so you're getting y plus 1 y over y dy. So as the x over dx, so we have negative here, negative x minus 1, and x divide x here, so you have multiply, divide x, and dx, we're moving here, right? Can you see that we already separate it into 2 parts, one left hand side and right hand side, which the left hand side all in terms of y and the right hand side in terms of x. Okay, we have applied the technique of separable variable. So later on, after we separate the variable, we integrate both sides. Right? We integrate both sides. Okay, before we integrate, we simplify the integral, right? So y over y, we have 1 plus 1 over y dy. And for this, we have negative x, right? Negative x over x. So we have negative 1, right? Negative 1. Negative, negative, positive. Positive 1 over x dx. So then after we already done with simplify, so we can integrate. Integrate 1, so we have y. Integrate 1 over y, we have ln modulus y. Integrate negative 1, we have negative x. Integrate 1 over x, we have ln modulus x plus c. Alright, so this is a general solution for this differential equation. Hope you can understand. And let's move on for the third example. Alright, let's go on to this third example. It's the same cases here. I have to tell you that this is the differential equation, first order differential equation with separable variable, types of separable, which we can separate the variable here. So as I can see that there is no y here, so there is only dy and 1 minus y. So I can write as 1 over 1 minus y dy on the left hand side. And these two are going to move to the right hand side, right? So I have cos x dx, right? Divide, multiply, and this is multiply on top. So we cross and we're getting sine x, right? Sine x. After we have already separate, so we put integrate both sides, right? So it's a simple concept. So for these cases here, is integrating this. We have linear, right? This is linear. So, and this is 1, so it's okay. You can refer to the video for chapter 1, okay, about integration, about the formula, the part that the 1 over ax plus b, right? The concept there. So for this case here, it's a linear, so with ln 1 minus y, but don't forget, in front of y there is a negative, so we have to divide by negative 1, which gives me negative ln y 1 minus y. So as this, we can apply the concept of, we can using this formula, right? This formula, or can apply substitution method, as this is actually integrate cotangent, right? Integrate cotangent. So as you are getting ln modulus fx plus c. So it means that you must be very good in integration before you're solving differential equation. So ln, for example, these cases here, we have fx as sine x, right? And if we differentiate, you are getting cos x, which exactly obey this rule, this formula here, as you see that fx is sine x, f prime x is cos x. So we can rewrite this side here as ln modulus sine x plus c, right? And this is the solution for these cases here. Alright, we will go for more example in the next video.